little bit of review. So at the very top of this page are all of your laws. Let's go over the most recent ones that aren't grade 9. We're on page 99. So we have covered integral exponents and rational exponents. Integral just means integer, which specifically they're talking about negatives then. So if I have a negative exponent, I change it to be like a fraction, and this would become x to the power of m in my denominator. What we learned last class was talking about fractional exponents that become radicals or roots. So in those cases, it becomes the nth root of x to the power of m, or you could put the m on the outside and you get the same value at the end. So that's like our new things. Today we're going to not really learn anything new, but we're going to emphasize a little bit more what we learned yesterday. So it says write each power as a radical. This is just converting it to have a root symbol. So radical just means that root symbol is there. It might be a square root, a cubic root, whatever, but some type of root. So the power of 1/6 is just going to become 6 root x, or the 6th root of x. When on b, when there's a negative like this, remember you should think of it as -1 times y to the power of 5/4. So the negative actually doesn't go in your root symbol there. So in this case, we get like -1 times the 4th root of y to the 5th. Versus on C, because those brackets are there, the negative is now included into my radical. So it would be the cubic root of -z all to the power of 5. Slight minor change on D is now I have a negative exponent. So I personally would first get rid of that and rewrite it, or at least think of it like this in my head. Convert it to that positive exponent, and then I would write it as a radical. This question is actually kind of a terrible question, as you're going to find out later in your math lives. You don't like radicals in denominators. So later on in grade 11, you're going to learn that you could never leave an answer like this. It's kind of like a fraction you always have to reduce. You can't ever leave roots in your denominator. That's a future problem, so don't worry about that. Sorry, say that again? Claire, go ahead.
Why wouldn't you have the whatever root and then inside of it put 1/.
Oh, I'm sorry. I missed rewriting my negative. Okay, sorry, Claire, say that again.
Why wouldn't you put the 1/z as 1 unit that's being.
It would z.
Why wouldn't I put it as 1/z
I know, I'm with z.
and then all of that to the 5/3?
No,
Like that?
1/z to 5/3, but then you would put it in radical form, as a fraction.
Like just go one step right to here?
No, put the radical, but then inside, where you just have the z right
Oh,
now,
like this?
Yeah.
Because that's a really good question. So you're saying to do it like that. Okay, I see what you're saying. In order to have it like that, you would have to have it would be z to the power. Okay, I have to work backwards. I see what you're saying. So you're saying if it was a radical with 1/z, could it just be z squared? Could it be like that?
No, you just have a fraction in it, and then proceed as usual.
Yes, because this would have been then the equivalent of 1/z all to the power of, let's say, a half in this case, which then could have been z to the -1 to the power of a half.
Okay.
So depending on the numbers, they could end up being equivalent.
Oh.
But it would depend on like your scenario. That's a really good question. Sophia?
For E, like when you have like negative E, you have to keep it in brackets.
Yes. The brackets are there, keep them there.
That's just like a bracket in question, like with a negative, always.
Yeah. It's just not going to mess you up. On E, is that 5 included in my exponents or not?
No.
No, good. So that 5 is going to come out front of your radical. So it's going to be 5 and then the 4th root of t cubed. So that would mean like 5 multiplied by, you don't need brackets here, but sometimes they help to emphasize things. You would do the operation like that. You know, those brackets are like super unnecessary, but it just implies a little bit better. Versus on F, the 5 is now included, so it would be the 4th root with 5 within my radical. How's that? Okay. Okay. Class example 2. Simplify the following. Write each expression as a power with positive exponents. Our goal is almost always to have positive exponents. Then as an entire radical. So clean it up, then write it as a radical is kind of what they're saying. If I don't have an exponent, it's to the power of 1. That being said, my first exponent here is 3 over 2. So let's, because we have to use fraction operations, I'm going to write this exponent as 2 over 2. 2 over 2 is equivalent to 1, but now I can add my fractions. So when we add fractions, we only add our numerators. So I would go 3 over 2 plus 2 over 2. You do not have to show that step. But that would give me 5 over 2, which is then the square root of x to the power of 5. Your calculators will do fraction operations for you, but we're not letting you have calculators. As well as you should know fraction operations. You've been doing this since grade 7. 1/3 minus 5/3. I'm dividing, so I'm going to subtract. So that gives me negative 4/3. So positive exponents first gives me 1 over y to the power of 4/3, which then as a radical is 1 over the cubic root of y to the 4th. On C, I have to multiply. So whenever you have exponents with a bracket in between the two exponents, so like exponent, bracket, exponents, I'm multiplying them. So this is going to become 1 times 2 gives me 2. 2 times 3 gives me 6. Reduce where you can. It's just, it makes it easier, and it makes your numbers a little bit nicer. So 2 over 6, I can reduce to 1/3. Realistically, it doesn't matter. You're going to get the exact same answer because it's still a fraction. But if you're having to evaluate it, it's a lot easier to figure out the 3rd root of something versus the 6th root on your own. So then this would just become the cubic root of a. On D, to make it a positive exponent initially, I'm just going to reciprocate the inside. So I'm going to change this to be y over y squared. Sorry, y over x squared, all to the power of 1/2. A question like this, you can answer a couple different ways, and this is kind of what Claire was getting at. So from here, you could say this is then the square root of y over x squared. Or you could apply that 1/2 to each of them and say it's the square root of y over the square root of x squared. What's the square root of x squared? X. Good. So then that simplifies a little bit more. Both of those answers I would mark equally correct. They do look very different though. Go ahead, Claire.
For this, like the first one, which is the x or y over x squared.
Yep.
Is that like the simple equation?
Technically speaking, you could simplify it to this one too.
Okay.
It's a little bit harder to see that, so I would be very fine if you left it here. Your answer is going to end up being the exact same regardless. For grade 10, that's fine to leave in that form. Okay, look at these next ones. They look even scarier. So basically, from rest today, the questions get scarier and scarier looking. So on this first one, the 3 times the 4, we can do that. So let's multiply 3 times 4. So we get 12. Then I can combine my exponents. So I'm going to go 3/4 plus negative a half. So really, I'm just going 3/4 minus a half, which leaves me with a quarter. Not on my 12 though. That's all the work I would expect you to show here. And then that is 12 times the 4th root of x. On B, deal with your numbers first. So 25 and 5, I can reduce to become 1/5, right? 5 goes into both those numbers. So let's just reduce that. Then I have 2 x's, so I'm going to subtract a negative, which means we're adding. So really, I'm going to go 3/5 plus 3/5, which gives me 6/5. Then when I clean this up, my 5 stays in the denominator. This is going to become the 5th root of x to the power of 6. I didn't rewrite my 1. If you want to, go right ahead. It's kind of whatever works for you there. Okay, let's turn your page. So now we're going to go in the opposite direction. So from a radical to a power. So in the first example, remember whatever our index is or that little number is, that becomes your denominator. So this first one is going to become a to the power of 5/3. Next one is going to be a to the power of 2/5. When there's not a number there, what's actually there? 2. Good. Sneaky hidden number 2. So then we get a to the 9/2. D, I think is, like, it's kind of misleading. You have to think about it a little bit more. So first off, this is going to become 1/a to the power of 7/2, which they specified in the question. I didn't point this out at the beginning. They just want it, like, not written as a fraction. So then I could take this a step further and say it's the power of negative 7/2. I don't love that question because I feel we teach you guys never to leave your answer as a negative exponent. So I feel like that's, like, not good teaching. These questions on, like, number 5 are where we're going to, and this is where it's actually going to come from. Question 4, as painful as it is, are like level 0 questions. Yeah. Like, I'm not gonna give you those kind of questions, because if that's all you can do, to me, you're barely passing. That's kind of what I'm getting at. I know. Okay, so 1296, I don't expect you to know this number. Okay, let's go over it, but I will not give you a number this big. So work on your outside in when you're converting. So when I change this first radical on the outside, I would rewrite this then to be the square root of 1296 to the power of a half. Now when I change this bracket, so just with the one root symbol of 1296, that becomes 1296 to the power of a half to the power of a half. So I had two roots, so I have two halves. Now I can multiply those together based on our exponent laws and get it to the power of a quarter. If you act, I would never give you this one. The fourth root of 1296 is really what this is asking, is 6. But I do not expect you to know that. This next one is going to be like 1 over 169 to the power of a half, which then is 169 to the power of negative a half. This last one, again, you're working like on your outside, working in. So I'm first going to deal with the cubic root. Which is then to the power of a third. Square root of 64 is really 64 to the power of a half. And then all of that is to the power of a third, which then I can multiply those exponents, which gives me 64 to the power of a sixth. Go ahead, Khalil. No. For this unit, you can show as little work as you need to show. There's lots of different ways to do it. And there's lots of different approaches, and lots of this can be easily done in your head. So as much work as you need to show, you need to show. Like if I was doing this one, I would be able to go straight to this last step. I might show this step just so I don't mess up if I'm having a day kind of thing. I might show that step, but you can easily go directly there. Okay, I want you to try. Do I want you to do these ones? No, let's do these together. Let's look at C. When you have exponents written, sorry, these aren't exponents. When you have two numbers, like a coefficient and a variable under the same radical, you can actually split them up as well. So this is the same thing as saying the square root of 900 times the square root of x. What is the square root of 900? 30. So then I could rewrite this one as 30. They want us to write it as like an exponent. So then I would write the root x as x to the power of a half. Is that one okay? Let's look at D. So in this one, let's rewrite them both as our exponents. So the first one's going to become x to the power of 5/3 times x to the power of 1/3. I'm multiplying two numbers that have the same base, so I can add my exponents, which gives me 6/3, which I can just reduce to 2. Let's do E. So E is going to become 2 times x to the power of a half. Be really careful. Like they try and make their multiplication symbols like not in italics kind of thing. I think it's a little bit confusing. But you're going to get x to the power of a half times x to the power of a half. Sorry, to the power of a third. In order to combine these, I need a common denominator. So this is now, common denominator here is 6. So this is going to be 3/6 plus 2/6. you don't need to show that step, that's just fine. How is that? Good. It's kind of building a little bit on what we did yesterday, just converting between the forms. Okay, that's it for today. I have quite a few practice questions for you today. I know it's a lot. And then you can have some time in our next class to work on them in addition to that review kind of booklet I'm going to give you. It is already 3 by the time we would get outside. You guys aren't going to have a ton of time to work, but I would say please go in the hall because this room is suffocating. And you guys can work out there like you normally do anyways. Go ahead, Khalil.